Hello guys, and welcome to this video. So in the last class I gave you an assignment and I wanted you to solve this integral. So I believe you solved it, and some of you must have dropped your answers in the comment, but just in case you found it difficult to solve, let's do it here together. So solution. Now, to solve this integral, I is 0 to 1, integral from 0 to 1, x to the 4 and the square root of 1 minus x squared dx. So remember, our beta function for m comma n is integral from 0 to 1. So let me use the variable u raised to the power of m minus 1 and 1 minus u to the n minus 1 du. Okay, so this is my beta function. So if you want to solve this integral, just look for a way to change the form of this integral into the structure of the beta function or the beta integral. Then along the way, when you make the changes, then you'll be able to figure out a way to solve for the integral. So having this integral, this is how I'm going to do. First of all, I am going to use the law of indices on this term over here. So 1 minus x squared raised to the power of 1 over 2, that's right, dx. So if I compare this with the structure of the beta integral, the independent variable here is alone, but I can see that here it is squared. So I need to convert this one to a form that is having an independent variable that is standing alone. So I'm going to use u. So put u equal to x squared. So what are the effects of making these changes on the boundaries? For u to be x squared, when x is 0, u will be 0 squared, which is still 0, and when x is 1 over here, u will be 1 squared. Okay, and when you evaluate 1 squared, you get 1. So we found out that the changing of the variables from x to u does not influence the boundaries of the integrals. X goes from 0 to 1 and u also goes from 0 to 1. So the integral boundaries will stay as it has been. Then the next thing to do is to make some critical replacements. So looking at this term over here, I'm going to need to replace it. What I have is x squared. So an intelligent way to actually get the representation of x raised to the power 4 is if we square both sides from this point, this checkpoint. So if I square both sides, I'll have u squared is equal to x raised to the power of 4. So I can just save this one for something else. So I also need to find a way to replace what? Dx. I also need to find a way to replace dx. So that is where we have to differentiate. So when we differentiate, we'll have du is equal to 2x dx. Is that okay? So if you make dx the subject, dx is equal to 1 over 2x du. So we actually need to find a way to represent u in terms of x. Is that okay? So from this particular checkpoint, given that u is equal to x squared, it implies that x is equal to the square root of u. So dx is 1 all over 2 root u. And you now have what? Du. So we have this over here. We have x4 over here. And we have x squared over here. So let's change the integral. So you will have your I to be integral from 0 to 1. So the first term of the integral is x to the power of 4, which is correspondent to u squared. Then 1 minus u in the bracket. Remember, 1 minus what? X squared being u, then raised to the power of 1 over 2. Then dx is 1 all over 2 root u. Is that okay? So if we bring out the constants, I can see 1 over 2. I'll bring it out. Then I have integral from 0 to 1. So I have u squared all over root u, and I have 1 minus u raised to the power of 1 over 2 du. Okay, so we have I to be 1 all over 2, integral from 0 to 1. Applying the law of indices, you're going to have u squared minus 1 over 2, because this u squared all over root u is still the same thing as u squared all over u to the half, and this is u2 minus 1 over 2 by law of indices. So you have 1 minus u to the 1 over 2 du. So at the end of the day, we're going to have I as 1 over 2 integral from 0 to 1. Then we now have u raised to the power of 3 over 2. Okay, then 1 minus u raised to the power of 1 over 2 du. So at this point, you can now compare with beta of m comma n, which is normally integral from 0 to 1. Then you now have u to the m minus 1, then 1 minus u to the n minus 1 du. Is that okay? So from this integral, you can compare and you discover that 3 over 2 is equal to m minus 1. That means m is equal to 3 over 2 plus 1, which is 5 over 2. Similarly, 1 over 2 is equal to n minus 1. Therefore, n is equal to 1 over 2 plus 1, which is a 3 over 2. So with this, we have our I as 1 all over 2. Then the whole of this is equivalent to saying beta of m comma n, where m is 5 over 2 and n is 3 over 2. Is that okay? So at this point, we can have I to be 1 all over 2. Beta of 5 over 2 comma 3 over 2 translates to gamma of 5 over 2, then gamma of 3 over 2 divided by gamma of 5 over 2 plus 3 over 2. Is that okay? So you have 1 all over 2, and you now have gamma of 5 over 2, gamma of 3 over 2, and divided by gamma of 4. When you add 5 over 2, which is 2.5, to 3 over 2, which is 1.5, and you get a 4 there. So of all these values, I know that gamma of 3 over 2 is root pi over 2. This is something you should be very conversant with. Then we know gamma of 4 as 3 factorial. So how do you find gamma of 5 over 2? So in one of the videos, I introduced a formula for finding the gamma of what? Half integers. I introduced the formula, and the formula goes like this, that gamma of n over 2 is given to us as you have root pi, then divided by 2 raised to the power of n minus 1 over 2, everything multiplied by the product of all odd numbers from 0 to n minus 3 over 2. Then you now have 2i plus 1. So this is a formula that I introduced that could help you evaluate the gamma of half integers such that n is greater than or equal to 5. And I specified that this formula is helpful when you want to evaluate the gamma of numbers of half integers where the numerator n is greater than or equal to what? 5. So if you want to apply it to finding gamma of 5 over 2, so this is what you're going to get. Gamma of 5 over 2 is going to be root pi divided by 2. So 5 minus 1 gives me 4, and 4 divided by 2 is 2, and I now have pi. This pi is not the same as this one. This pi means product. I hope you know it's a product operator, just like this one means summation operator. You're summing all items from I equal to 0 to I equal to n, but we are multiplying all items from I equal to 0 to I equal to this value. Now, what is this value? This value with n equal to 5 will depend on 5 minus 3, which is 2 divided by 2, which is what? 1. Is that okay? So we have from 0 to 1 and 2i plus 1. So where is this gotten from? This is the general representation of all odd numbers. So if you expand this, you're going to have root pi all over 2 raised to the power of 2. Then you're now going to have 2 into 0 plus 1. Then that's when I is 0 times 2 into 1 plus 1. That means when I is 1, and that is where the product stops. So in evaluating further, your gamma of 5 over 2 is now going to be root pi all over 4. Then we now have 2 into 0 is what? 0 plus 1 is 1 times 2 into 1 is what? 2 plus 1, 3. 2. So 1 times 3. Okay? And eventually this gives me 3 root pi over 4. So the gamma of 5 over 2 is 3 root pi over 4. So putting everything together, we have our I as 1 all over 2 gamma 5 over 2 gamma 3 over 2 divided by what? Gamma 4. So this is 1 all over 2. Gamma 5 over 2 is 3 root pi over 4. Gamma 3 over 2 is root pi over 2. And gamma 4 is 3 factorial. So this is going to be, if we solve, we'll have, let's just do some little simplification. We'll have 3 pi. Root pi times root pi is pi. 10 times 3 is 3. 2 times 4 is 8 times 2, all over 16, then divided by 3 factorial. So this eventually will be 3 pi all over 16 times 3 times 2. Okay, for 3 factorial times 1. So 3 is cancelling out 3. So at the end of the day, we have pi all over 32 as the final answer. So the final answer is pi over 32. And if you want to simplify pi over 32, pi over 32, pi over 32, let's just get the value with a calculator. So we have pi divided by 32, 0.09817. So if you got this, congratulations, you've got the answer. So this is basically how we do gamma and beta functions. So from here onwards, I want you to try to solve as many questions as possible as your hands find on gamma and beta functions. And if you have any question that is so difficult for you to solve on gamma and beta functions, please drop it on the comment sections or try to reach out to me, and I'll be glad to help. Please like this video and subscribe to my channel and share to your friends, share to institutions that will be interested in learning about these topics. And till the next video or general topic, I want you to stay blessed. So bye.